Welcome to Brain Vision.
In part A, we're asked to find theta and phi. The momentum of the photon before scattering, p0, is equal to h minus lambda 0. And after scattering, its p prime is equal to h times lambda prime. And we also have conservation of momentum in the zx direction, and that's given by p0 is equal to p prime cosine theta plus pe cosine theta, where pe is the electron momentum after scattering. So we can use these equations now. H lambda prime is equal to h lambda naught is equal to h lambda prime plus pe times cosine of theta. And in the y direction, we have conservation of momentum, so we have 0 is equal to p prime sine theta minus pe sine theta. So we can use these to solve for lambda prime. And we also need to, we have a shift in wavelength known as a Compton effect. So the Compton effect equation is lambda prime minus lambda 0 is equal to hmc 1 minus cosine theta. And we can use all of these equations to start putting them together to solve for theta. So it would be lambda prime minus lambda naught is equal to hmc times 1 minus cosine theta times 2 lambda naught cosine theta minus lambda naught. And let's solve for theta. And we can plug in all of our values that we know. So we have 0.511 MeV for MEC squared, 0.880 MeV for E0, and we want to solve for theta. So if we plug in our values, we get 0.511 plus 0.880 times 0.511 plus 0.880 is equal to inverse cosine is 0.731. So the scattering angle is 43 degrees. So our scattering angle is going to be 43 degrees for this problem, which is also equal to phi. So theta and phi are equal to each other, and that's equal to 43 degrees. Next, we're asked to find the energy momentum of the scattered photon. So E prime is for the scattered photon, which is hc lambda prime, and P prime is E prime times c. So we can use what we have. We have E prime is equal to 0.880 times cosine of 43 degrees, and we get 0.602 MeV. And for P prime, it's 0.602 times 3 times 10 to the 8, and we get 3.21 times 10 to the negative 22. So for part C, we want to find the kinetic energy and momentum of the scattered electron. So kinetic energy is equal to E naught minus E prime, and PE, which is the PE is equal to P prime. So KE is 0.880 minus 0.602, and we get 0.278 MeV. And our PE is, again, 3.21 times 10 to the negative 22.